now we can put it away. Awesome. All right, so what are we doing today? We need to discuss the syllabus, that's one. And then we need to discuss data analysis. I'm gonna start with the syllabus, and yes, I'm gonna share with you, I already shared the actual syllabus. I'm gonna share with you this PowerPoint. I'm gonna go quickly over the syllabus. I will tackle only the main ideas because I want you to be aware of some very important things. Stop me at any moment, okay? The outline, description of the lab, I mean, what the lab is about, what do we cover in the lab, the course learning outcomes and how close we can come to it through online teaching, when do we meet and when and where, this is general, the grading system, and how are we going to deal with the lab reports. First, you will expect to cover a lot of mechanics related experiment like projectile motion, motion on an incline, centripetal force. You will reach eventually some oscillations and wave related experiments. You have some rotations happening. This is buoyancy in fluids in a liquid. This is for standing waves. Probably you've heard of some of those in high school. This is linear expansion and basically heat. What happens if you heat up a certain solid? You know, it will expand. Specific heat capacity. Probably you did not cover this in physics, probably in chemistry. When you have two objects of different temperature, you mix them together, one would lose heat, one will gain heat. MC delta TC is the specific heat capacity. So we're gonna do this experimentally as well. All right, so a mix of mechanics under rotation, some waves and standing waves, some fluids, and eventually heat. Okay, it's very similar to physics 301 that you're taking the course. Usually you follow the same order, but sometimes the lab would go slower or faster than the course. Please let me know, share that with me. Now the course learning outcomes that you find in the syllabus, I want you to know that it's very important to remember that the lab is about teamwork. The lab is about data analysis along with the physics. You would be disappointed when you will know that we will do a lot of data analysis because a lot of students don't like this. Especially the students that are bright in physics, they have a lot of confidence and they're like, we're good in physics. I don't want to do data analysis. We hate data analysis. We don't want to study data analysis. How come I'm failing physics lab? I'm good in physics. So I want you to know from day one that data analysis is very important. It's tough, it is required, and that's why we have today data analysis as one independent session that I'm gonna break into two parts, part one for today, part two for later on, because I believe I need to take my time for every piece of idea. All right, so please do not ignore data analysis. I'm sure you will have difficulties. Just let me know. We can meet anytime you want and we can repeat things together. All right, so now when do we meet? I want you to be aware that we are 6 sections. That's a lot. You are this section. Officially, your lab starts at 1:30 and ends up at around 4:30, 3 hours. Officially, this will happen in the physics lab, which is Zachem Engineering Hall 604. Since we're online, give yourself around 90 minutes. So allocate 90 minutes of your time. I'm gonna try my best to finish between 60 and 90 minutes every week. I'm talking about the online live sessions. And you will do your lab report throughout the week. If we are in the lab, usually you do the lab report in the lab, all right? So the 3 hours are gonna spread over a week, 90 minutes of which are gonna be our online session, all right? It's 1 credit. You can see the schedule here. What does it say? It says introduction for today. This is the week, you know. I did a mistake. That's Monday. So Tuesday is basically similar, but next Tuesday, if I'm not wrong, it says holiday. Let me show you the actual syllabus. How did I forget? Okay, is that the syllabus? I think so. How did I forget to upload Tuesday? For me, you are the same. All right. So you see, it says Tuesday introduction, and next week we don't have lab, which means our Monday section is gonna be ahead. It's good for you to know. Anyway, the midterm is common and it's going to be TBA. So we're going to decide later about time and date. And I think the midterm is going to cover only 1, 2, 3, 4, because 5, you need a week to finish it. So it will not be included. Back to our presentation. So basically, this is the order of the experiments. We have a midterm around lab 5 and then a final exam. The midterm will cover, I think, the first 4 experiments, and the final exam will cover experiment 5 to 10. So it's not cumulative. What's the difference between midterm and final exam? There's no difference. The only thing is midterm is a mini final exam and just for you to try. All right, we don't want you to surprise in the final exam. All right, so next. So we will always meet on this link. This is my email. I know we have office hours on the syllabus. I don't want to follow them. So anytime you want, every day, just let me know and we can meet on the same link. All right? So I think it's more efficient if we can meet every time you need me. The final is cumulative, no. So from lab 5 to 10, but eventually we will confirm. We will let you know, but it was never ever cumulative before. So it's only dividing the experiments into 2 chunks. All right, any other question? Now the grading system, it's gonna meet midterm 25%, final exam 25%. So we're gonna divide both. The lab reports, which are actually 10 lab reports, introduction is not graded, will be 50% of your work, of your grade. The lab reports can be done teamwork, which means you can do it alone or with one partner. You don't have to go through teamwork. It's optional because I know you may not like to have a partner since we're online. In the lab, like on campus, it's way different. But online, we gave you the option. Please don't be 3 students doing one lab report. It's either 1 student or 2. Okay? Let me explain a bit how it's gonna be for the lab reports. You will be given a manual. You will be given a lab report to fill in. So you're not writing your own lab report like in high school, and you're not doing it like we do in chemistry lab. I know in chemistry lab, probably you need to write your own lab report. Here, you simply need to fill in the tables and to answer the questions. So I'm gonna give you a doc version of this file and a PDF version of this file. You pick what you're comfortable with. You fill in the blanks. You write the date and the names because you may be 2 or 1. Keep a copy for yourself, a copy for your partner, and each partners, like, they need to upload their work. For example, if I have again a look at your names, where are the names? They are here. For example, let's say George and Zilla are working together. Zilla will submit her work and George will submit his work. It's gonna be the same file, I know, but please, both of you would need to submit the work. Otherwise, I'm gonna see missing work for George. So since I cannot follow each and every one of you, I will see that everybody submitted something. And every time I go to grade it, I will see George and Zilla. So I give you the same grade. So I'm not gonna grade it twice. And please, under no condition, don't work with a partner without telling me both names. Like, for example, Rita and Clara, let's say you work together, make sure you mention under names Rita and Clara. Otherwise, I will grade Rita and Clara independently. And this is a lot of me giving a time from myself and becoming slower to give you back your grade. So if you know you work together and it's officially allowed, mark both names, okay? Sometimes you would forget, you will write your name only. Now, how would you submit your work? Under Blackboard, that I suppose you're now familiar with, you will find, let's say, Lab 1. If you click into Lab 1, you will see experiment, lab report, submit here, recorded session. You go into submit here, and you submit, you upload your work, okay? We always ask the student to submit a PDF version of their work, because if you submit a doc version, probably it's gonna look different, a bit different on Blackboard. So for you to make sure your graphs and tables and equations are not mixed together, Make a PDF version of your work, then submit it. All right? I will be very picky, especially for the first lab. I want you to remember a lab report is an official something you present to me to start with, eventually to your customer, to your boss, to your patient. So it has to be official. I mean, you're gonna use Times New Roman, you're gonna use font 12, and everything should be in one file. So I'm not expecting you to give me a file for the graph, a file for the tables, pictures from here and there. Make sure you insert everything in one document. Convert to PDF, then upload. If you will have technical difficulty throughout the semester, just let me know. I can do it for you. All right? So that's it. For the first few weeks, I may ask you to submit again if I believe you need to change a bit your lab report. Now you will be expecting this. These are screenshots. Yes, Yara, what's wrong? What do you want? You can do whatever you want. Do not interrupt me. You want paint. Hello. Ya Allah. All right. So now she's taking paint to her room. So try to imagine the mess. Please be careful. So yes, this is Yara, and I can see that we have Yara on the list of names as well. So I'm overwhelmed with Yaras. So I was saying these are screenshots of a video for motion on an incline. So you will expect a video done by me. I will try my best to make it as clear as possible. You need to know that I don't have a team working with me to make those videos. So this is like homemade video. I'm using my phone, which is not great as well. So if you do believe things are not clear, just let me know. Okay? Yes. So that's it for the syllabus. I'm going to share this with you. I think now we are ready to start data analysis, which is here. I'm going to modify this file and send you the modified version of it. Any question before I continue? All right, so data analysis, outline. And we need to cover 1, 2, 3, 4. We still need to add to this list, item 5 and 6, that I'm going to do later. Okay, I'm not in a hurry. I just need to make sure you guys know this very well. And I'm going to move this a bit to keep on looking at your names. Significant figures, what they are. For the students who already did the French back, you know a bit more than the other students, but I'm going to do everything from scratch. Measurements, how we do them. What tools do we use, uncertainties on the measurements, and then averages. When do we do averages? How? What is the uncertainty on an average? Whenever we calculate a value, how do we find the uncertainty on a calculated value? All right. One, significant figures. You can see here some values, some numbers. As a scientist myself, looking at those numbers, I know these are measurements. You guys, for me, you're still high schoolers. Looking at those, you would think they are numerical values. So that's why we may not agree on many things. So, and I don't blame you, because since 2 years old, when you were 2 years old, you knew that numbers are mathematical numbers. You never had the chance to think about these being measurements. So one, make sure you always have a unit. Okay. Two, I want you to look at the last two examples, $500 and $500.0. Mathematically, this is the same value. Experimentally, or if you think of these being measurements, they do give you different information. I need someone to tell me, how are those two different? Anyone?
Yes, me.
Yes, Rita.
$500 feel one significant figure.
All right, Chinese for me.
Yes. 500.04 significant figure.
What difference does it make? Will I have my $500 eventually?
Yes, no more precise, يعني.
All right, so when we say $500.0, this is more precision, so more information.
Okay.
But if I tell you $500, yes, it could be 400 or 600, but 500.0 will fluctuate between 500.1 and 499.9. So the range of precision is smaller, and it means that this guy has more information. And since we're writing a lab report, we need to give information to someone who's reading the lab report. And this, when we write this, we mean something. And when we write this, we mean something else. I'm going to give you an example. Let's say your doctor tells you to take medication and he says 1 spoon. It's not very precise. He has reasons not to be precise. Probably it doesn't matter. And probably he can tell he wants you to take 1.0 milliliters. That's more precise and it makes a difference. So it's different information. That's all. Now let's try to write the number of significant figures. Probably I can show you the rule first. What does it say? It says that all the zeros or non-zero digits, we do count them. They are very important. The trailing zeros, we do count them, especially that I have a decimal point. So yes, this is counted. If I don't have a decimal point, I do not count it. So probably I can say this is counted, this is counted. The zeros between two non-zero digits is also counted. The leading zeros or the zeros on the left are not counted because I can simply replace them by something times 10 to the negative 3. Right? So they are here to give me the order of magnitude, but not to give me information. So these are the rules. Back to this one, Rita, I need your help. How many significant figures do I have for the first one? This one. How many sig figs?
3.
All right. Yes,
3.
Ariel, you're right. The next one, can you help me with it?
3 also.
3 also. And this one?
2.
Next?
1.
Okay, so as you can see, the leading zeros, we do not count them, but the trailing zero is counted. Continue, Rita.
4.
4, and then?
1.
And then 1.
1 and 4.
And this is 4. So these zeros are trailing zeros, yes, but I don't have a decimal point, so I can replace this by 5 times 10 to the 2. Okay, so this is the reason why we do not count those zeros. I don't know if this makes sense to you. Let me try another example with Naya. And please let me know if you want me to go back to this, if you have questions. Yes, Naya. So I've hidden the answers. They are behind this. Can you help me with this one?
5.
Okay, this one.
The second one?
Yes, let me zoom in so you can see it. How many significant?
Yes, please. 4.
4. Next. Be careful, this is a comma to say it's 100,000. 6. Oh, be careful, the last 0 is not counted because you have a comma and not a decimal point. So this is 5 sig figs. This one.
5. 3.
3. And this one.
2.
And this one.
2.
All right. So probably I can ask you to repeat this later. Okay, that's why I did not mark the answers. Okay, now we need to discuss measurements. Okay, we need measuring tools. Let me close the door behind me. So I'm back to you. Probably ask Joseph. Joseph, are you with us? Josephina. Josephina,
Okay.
are you with? Yeah. So Josephina, right?
Yes.
Okay. I want you to tell me this morning, I'm sure you used some measuring tools. Can you give me some examples of measuring tools you used this morning?
Ruler.
Okay, you did use a ruler this morning. Okay, what else? That's it? Probably Yara can help. Measuring tape, clock. I like this. I just read in the chat. So measuring tape is also a measuring tool. The clock could be a measuring tool. The balance, you mean the bathroom scale? Yes, it's a measuring tool. I used a thermometer in my car. It's a measuring tool. What else? A spoon is a measuring tool while doing coffee. Anything else you'd like to add? I think that's enough. Now we're gonna divide our measuring tools into digital and analog. Okay, and I stay with me, Giuseppina. So digital measuring tools, digital measuring tool or digital and analog. Can you tell me or try to explain the difference between digital and analog? Yes?
Doctor, it's lagging. I didn't hear.
Okay, let me hide my camera for a moment. It could be my camera. All right. So my question is, can you tell me the difference between digital and analog? I'm still glitching to you. All right. I'm reading in the chat that analog has a needle, digital has a number, it has a screen. The watch could be digital. Yes. All right. So the ruler, is it digital or analog? It's analog because it doesn't have a screen. So we don't need to have a needle actually. Measuring tape is also analog. Clock can be both. I mean a stopwatch. A balance can be both. The one I have at home here is digital. Thermometer can be both. The one I have in my car is digital. The spoon, what is it? Analog or digital? The spoon is actually analog. It doesn't have a screen, obviously. So thank you, Giuseppina, for your answers. Now I'm gonna ask Clara to help me with the measurement above. I mean by the measurement above, the measurement like the red line. I need to measure the length of the red line. Can you guess what the length is? So Clara.
Yes, it's 2.3
Okay, unit.
centimeters.
Okay, now we're gonna find the error on it. All right, the rule states that the error is the smallest subdivision divided by 2. All right, I want you to help me find the smallest subdivision. Yani the smallest jump, the smallest reading. Yeah, what is the smallest reading you can do?
I didn't really understand.
All right, so let me use a pen to show you. What is this very small reading you can do? The smallest reading.
0.1.
All right, unit?
Centimeters.
Okay, so I just took the smallest subdivision divided by 2. So 0.1 centimeters divided by 2 is 0.05 centimeters. That's the uncertainty or the error. Let me underline it on my measurement. Now the question is, how many decimal is this? I'm still with Clara, 2 decimals. You have to fix